No, but it's the same thing, even though.
Yeah.
Good afternoon. I hope everybody's doing well. Let's get to work. So, today's warm-up, I would like you to tell me the values of the variables in the diagram. Let's see how we did with this. And we will go with student numbered 18, 20, 1, and 8. Student number 18, what'd you get?
X equals 10 over 3 and y equals 14 over 4.
Student number 20, what'd you get?
X equals to 3 1/3 and y equals to 4.
You said 10/3? That's the same thing, I think. Okay. Student number 1, what'd you get?
X equals 3 1/3 and y equals 4 2/3.
Okay. Student number 8, what'd you get?
X equals 10 over 3 and y equals 4
Okay. So you actually got numbers. I wasn't really expecting that. Are you sure?
Yes.
Positive that it comes out to those?
Yes, I proved them similar and I did. I'm pretty sure.
You proved them similar.
Yeah.
You can you?
Yes.
How?
Well, you can use the AA since, as you can see, you can use since the two lines are parallel, and since that one over there with that 3, that line is a transversal, you can use interior angles and you can use the vertical angles over there to prove it with the AA.
Oh, so you proved them similar. I think I followed what you're saying. So you use this angle and that angle. They're congruent because of what?
Alternate interior angles.
And then what was your other angle?
The vertical angles in the center.
Oh, here in the middle. Oh, so you said this is congruent to that by the vertical angles, and then you said something about AA.
Yeah, AA similarity theorem.
Okay, so they're similar because of the AA similarity theorem.
No, postulate.
Postulate? I don't know really. That's okay. Okay, now we can say that. So why did I kind of put some emphasis on what he was just explaining? Well, this is my second go-around with this lesson, and the first time around I had a whole bunch of people who made an assumption. I had a whole bunch of students who assumed that they were similar and just proceeded with forming ratios, proportions, or whatever you did to find the values. But you have to spend the time to make sure that it will actually work out. Hopefully you remember that there was a checkpoint that I gave you not too long ago where you couldn't actually do anything because there was no evidence in the diagram to support what some students assumed was true. So you actually have to make sure that the evidence is there and that you can draw the conclusions that you're drawing and then proceed. Anyone have any comments or questions about that? Okay, give me a thumbs up if you got this correct. We had a lot of people who got it correct. Good, put your thumbs down. Any comments or questions, concerns, or issues? Okay, let's pause here. So today we're going to expand on our toolbox. We're going to take what we've learned and build upon it. When we've really only done 2 lessons so far in this chapter, yet we seem to be covering a lot of ground. When I did 6.1 with you, there was only one theorem, and there was a few ideas, but there was only one theorem. This is kind of the other end of the spectrum. Within this lesson, there's actually 4 theorems, but 2 of them are basically the same thing, just converse, And so it's not terrible, but it is going to be quite a bit to digest. But you'll also, I think, will make a lot of connections to some different ideas today. And I want to encourage you to look beyond what we're working with together. Look beyond it. Look deeper. Explore something that maybe is just something in that struck you in your mind that, well, I wonder if that would work, or I wonder if I could do that the other way. So anytime something like that pops up in your head, I want you to go to the side of your paper and try it out. Or raise your hand and propose it as a theory that we need to prove. This has already happened quite a few times. All right? So our objectives today are to use properties of similar triangles to find segment lengths, but the newest part is to apply proportionality and triangle angle bisector theorems. So we actually have 4 that we're going to be working with. There's no new explicit vocabulary, but all the terminology that we've been using is going to be applied again today. So to get us kind of in the right frame of mind, I want to talk about an idea. Give me a thumbs up if you, at any point in your young life, have been taught the idea of one-point perspective as it pertains to art. You ever taken an art class or anything, you've been taught one-point perspective? Nobody. I'm surprised. Anybody learn two-point perspective? These are just basic ideas that they're prevalent everywhere in our world. One-point perspective, when in the world of art, is a technique used to take something that's three-dimensional and draw it on paper. Because a piece of paper, like this that I'm holding, is two-dimensional. Looking at it, you can only see 2 dimensions. But we often draw things that are three-dimensional, like objects, humans, animals. And three-dimensional objects have depth to them. So how do we trick people into seeing depth when it's actually not there? So you're actually looking at a drawing that is using what is called one-point perspective. One-point perspective means that there is a vanishing point off in the distance that you pick. 1 point. And everything in the picture must vanish at that point. And so this three-dimensional park, this is an artist rendering of a park. If we actually went to the park and stood right here, it wouldn't look like this. We would see 4 trees that all looked the same, one next to each other. But if we stood all the way over here and looked down the path, it would look as though the tree closest to us was taller than the tree furthest from us. And so artists become very adept at simulating this by actually drawing things smaller as they get further away, but they don't do it randomly. Like, it wouldn't have made sense for this tree to be way up here, unless it actually was. And it makes much more sense this way, and what happens is, by doing that, you actually trick the human brain into seeing depth. And that's what you're seeing as you move this way, depth. And this is actually a mathematical idea. Artists end up doing it by instinct, usually. But you would actually be able to measure, if you took a famous painting that had depth to it, 1-point perspective depth, we could measure, and we would find that distances were actually proportional. And the artist was so good that they did it without measuring anything. They just had this incredible natural ability to simulate the depth. And so that's where theorems like the triangle proportionality theorem become really important, because they actually use it to create this. Any questions about this idea? So, let's look more explicitly at the ideas that we're going to be exploring today. Hopefully you have your cheat sheet already sitting in front of you. And so the first two theorems are really the same theorem, just one is the converse. So if a line is parallel to a side of a triangle and intersects or connects the other two sides, then it actually divides the sides proportionally. So we can form a proportion, and you see it here. We can form a proportion right here of this segment to this segment is going to equal this segment to this one, right there. That's if these two lines are parallel. If they're not parallel, then it doesn't apply. Now your brain should already be going, because I said the word converse already. You have the cheat sheet sitting in front of you. And so the converse is also true. And you've seen this many times this year already. That if we can show this to be true, then we have shown that the lines are parallel. So converse means going in the other direction. Hypothesis and conclusion flip-flop. If lines are parallel, then you get the proportion. If you get the proportion, then the lines are parallel. Any comments or questions about the triangle proportionality theorem? Yes? You've already seen this. I have a little note down here. The mid-segment theorem is actually a special case of this. It's actually the same thing, except the mid-segment theorem. This line is connecting the midpoints of the two sides. And since the midpoints, let's pretend that those are the midpoints, this midpoint divides this into two equal parts, the ratio will just be 1 to 1. 1 equals 1. So the mid-segment theorem is actually the same thing, it just works out even nicer than this does. And so that's why I came before, because it was a little bit easier to digest. Okay? Any comments or questions? Okay. The other two ideas today. You see on your cheat sheet, and I tried to do a good job, and sometimes I don't think of ideas or come up with things until after I produce something. So if you look at your cheat sheet, you'll notice the names of these theorems are different. And they're not good. The publisher of this book that we use named them numbers. I did a little searching around and I found another published book that's modern that had better names. Not easy names, but better names, because the names give you a clue as to what the theorem means. And so I need you to now adjust your cheat sheet, or cross something out and change it. The two transversal proportionality theorem is on your sheet called theorem 6.6. So we're going to get rid of the 6.6, and we're going to call this from now on the two transversal proportionality theorem. Again, that's some big boy language, but at least it gives you a clue as to what the theorem is all about. So now that we've got that adjusted, what does this theorem tell us? If we have three parallel lines, and in fact, if we have more than three, it still would work. If we had three or more parallel lines and two transversals, then the parallel lines cut the transversals proportionally. And the interesting thing is that this is actually the same thing as the other theorem. Because look at what happens if I connect this to this right there, and if I extend this all the way this way, and I extend this all the way this way, what would that form if I was able to extend those lines until they met? Kadir, what would that form? A triangle. And so now we have basically the triangle proportionality theorem, but now with the emphasis is on the parallel lines rather than the triangle itself. But it's still the same idea. And so now we can form a proportion from the transversals and where they're cut. Does anyone have any questions about that? So the first three theorems all kind of get wrapped together. The fourth one has a different name than what's on your cheat sheet, so I need you to adjust that right now. And it's called the triangle angle bisector theorem. Triangle angle bisector theorem. So this one's a little bit different, but we still have the same basic theme going on, is the proportionality that comes out of a certain situation. And so if we have an angle bisector, this is not a segment bisector. It looks like it might be, but we don't know if it is. This is an angle bisector, that's what these are indicating. Then we have a proportional relationship between this segment and this segment, that's here, and the sides of the triangle, here and here. That's what's right there. Anyone have any questions about that? Any thoughts about anything? Any concerns? Good, so let's start exploring and building our toolbox of investigative techniques. So, example 1A. You don't have to copy the text of the question, but the sketches are going to help when you need to refer back. So draw a sketch. Doesn't need to be perfect, it just needs to be accurate. So this is an example. This is not a checkpoint, but we're going to do something a little bit differently. I'm going to give you a minute. I would like you to discuss with your team and see if you can come up with the length of RQ. See if you guys can do it as a team. The length of RQ. You got a minute, go. Working as a team. Okay? So give me a thumbs up if you think you and your team were able to figure it out. Got team here, team there, team here, team there. Okay, some teams were and some teams were not. Okay, good. So, what'd you guys figure out, Zumar? Equals what?
6.
You think it's 6? And Stephanie, your team also said they figured out, what was it?
6.
You also agree it was 6? And I think, Alexandra, your team, what did you guys come up with? So you guys all think that RQ is 6. Okay. Matthew, you agree?
Yeah.
How did you do it?
X over 9 equals 4 6 because of triangle proportionality.
Say it one more time.
Proportionality.
No, the proportion.
Oh, x over 9 equals 4 6.
x over 9 equals 4 over 6. So you're calling the distance here x?
Yeah.
And you said that's because of which theorem?
Triangle proportionality.
Okay, so we have parallel lines, and this is a triangle. And so we end up with a relationship. This distance to this distance will equal that distance to that distance. So of course he's right. And so now you have your choice. You can do cross product, you can do shortcut, you can simplify it. There's a whole bunch of different ways to do it. But yes, absolutely, RQ equals 6. RQ equals 6. Any questions about that? Any concerns? Any observations that you've made or any theories that you'd like to throw out? Nothing at all. Surprised. Okay. So let's look at another scenario. Keeping in the back of your mind the idea that you need to be able to take something that you've learned, put it together with other ideas that you've learned at some point in the past, and apply it to something new or create something new. So in this situation, I would like you to demonstrate that the shelf is not parallel to the floor. Or maybe it is. I actually don't know if it's parallel or not. You're the first group doing this. But I guess from the publisher, the publisher is saying it's not parallel, but you need to prove it. So see if you can figure out with your team a way to demonstrate that either the shelf is parallel or the shelf is not parallel based on the given information. So you've got a minute to team talk and see what you can come up with. So, were you able to show that they're not parallel, or were you able to show that they are parallel? Anything? Give me a thumbs up if you were able to demonstrate something. Okay? A couple of teams? Good. Put your thumbs down. Extol, what did your team come up with?
Proportion for CD is 44 centimeters and D is 25 centimeters.
Okay.
44 is greater than 25 in proportion with D, and then CB is 27 centimeters and D is 33. That was put in the proportion. 27 would be less than.
Okay. What do you? So I got a little confused because you said proportion, but then you started saying less than and greater than. I got a little confused. Did you wrote out a proportion and then you observed something, or you just wrote inequalities, or what?
I wrote out a proportion that or something.
Okay, so you actually have a proportion that looks, looks like a traditional proportion with a fraction or a ratio on the left and a ratio on the right. Okay, so what was the left?
44 over
44 over 25. And then what was on the right?
27.
27 over 33. So what were you looking for when you set that up?
If they were equal.
If they were equal. And are they? No. Did you do cross product, or what did you do to figure it out that they weren't equal?
Because 44 is greater than 25.
Oh, so you're saying because this number is greater than that one, then what should be true over here?
That one has to be greater than.
Yeah, the top has to be greater than the bottom no matter what. So you can just look and you know that it's not equal. So because they were not equal, then what conclusion did you make?
That 4 is parallel with each other.
Very good. So he was, with his team, was able to prove that it's not parallel. Because if it was parallel, then there would be a proportion with this to this and this to this. Because if they were parallel, that proportion would be true. But that he formed the proportion because we have the information given to us here. But the proportion works out to be false, which means that they are not parallel. Does anyone have any questions about how they went about that? Okay, so that was Kadir's team's approach. That was Extol's team approach. Kadir, what did your team come up with?
Oh, we did the same thing.
It was the same thing?
Yeah.
Was it exactly the same or anything slightly different?
We simplified the other one, and then
You simplified which one?
27 over 30.
What does that simplify to?
9 over 11.
Okay, so you could simplify this to 9 over 11, and then what'd you do?
Well, then we see if they're not like equal because like you can't like multiply 9 times 8 like 44 or 11 times 8.
Oh. Okay, so you couldn't find a number that you could multiply this by and this by. It has to be the same number, and you couldn't find it. Okay, that's a good approach. Good. Anybody do anything different? Anybody have any questions about what's happening here? So here's an example of taking something that you just started learning and applying it in something totally different. Anyone have any questions? All right, so now you're totally on your own. Checkpoint number 1. These are independent. This is an independent assignment. You're going to find me YZ, and then you're going to determine whether these two lines are parallel. And then when you're done, then you can consult with your teammates. So we've got 3 minutes on the clock. And of course, if you have any concerns or issues, please let me know. And if any new ideas pop up in your head, anything different that you want to explore, I would encourage you to try it. working, take another minute to finish. I'm totally fine with it. If you're already done and your team is done, compare your answers with your teammates. Okay, now we're ready. So, what'd you get for part A? For part A, I've got student number 19, 2, 1, and 14. Student number 19, what'd you get? Part A? Okay. Student number 2, what'd you get? Say it one more time, Elsie.
20.6.
Okay, student number 1, what'd you get?
5.
Okay, student number 14, what'd you get?
28.6.
The correct answer was 28.6, 28.64. I'll take however you rounded it, as long as it's somewhere around 28.6. What was it?
28.7 over.
That's right. All right, and part B. Part B, we've got student number 17, 7, 5, and 4. Student number 17, what'd you get?
E is parallel to
Oh, so you got that they are parallel. Okay, student number 7, what did you put? They're parallel. Student number 5? Student number 4?
parallel.
So 4 of you think that they are parallel, and they are. So let's talk about this. The diagram only has 2 numbers, so you can't form a proportion that you can solve with only 2 numbers. So what did you do to fill in something? What did you do, John?
What I did, it tells me that AC equals 36. I just subtracted the ones that they already given to you in the picture from the total distance.
Okay. And you got what?
I got 16 for AD and 12 for BE.
Okay. So, oh, you took the information from here, subtracted what was given, and so you got 16 centimeters here, 12 centimeters here, and then you were able to form a proportion. Okay? What proportion did you form? Anybody else? What proportion did you form? Kamoy? 16 over 20 equals 12 over 15, and that comes out true? Did anyone do a different proportion? John?
I did 20 over 16 and 15 over 12.
Okay, so you can flip the whole thing and it still worked? Did anyone do a different proportion? Okay. Any, yes, Kadir?
Like, I think like if they're parallel, it's like the proportion for like it'd be like 20 over 6 or 16 over 20. I think like equals 4 over 5.
That's right.
And so like the other line, like in the same triangle, like the proportions will also be like the same. Like, yeah. The smaller side over the rest of it. So it'd be like 15 or 20. So, oh.
Well, you're onto something there. Keep thinking about it. Keep thinking about it. All right. So now, I put example 2A. It's actually just example 2. There's not going to be a part B. So just put example 2. And find the distance HF between Main Street and South Main Street. Again, this is not a checkpoint. This is an example for us to explore and to learn from. So let's see what you and your team can come up with. I'm going to put 2 minutes on the clock. I want you to see if you can find the distance of HF. Let's see who can do it. Go.
I think it's gonna HF. Oh, yeah.
No, it's 150 over 300. Yeah, it's 3 parallel lines UW over YW, right? So imagine the UW being ED and the YW being DC. ED over DC. So is it yeah, over GH.
No, G.
And then you find AHF. I got 360, let me know if you got
So give me a thumbs up if you figured it out. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, a whole bunch of people. Okay. So does anyone have a proposal for what HF is? Let's take some proposals. Stephen, what do you propose it is? You think it's 360?
Yeah.
Did your team agree with you?
Yeah.
Okay. Any other proposals? Sharik?
360.
Any other proposals?
okay.
Oh, but you would like to second this proposal, so you agree? Did your team come up with that as well? You all agree? Okay. Alexandra, what about your team?
Yeah.
Well, what did you think? I apologize. You thought it was 360, and then your team also thought it was 360. Okay. So we think that it's 360. Well, what support do you have? Where did you start? Someone give us a starting point. Nathaniel?
I was first at a second degree where angle 2 was, where it's 150 degrees of opposite angle. So that's half of 300 degrees. And
That's not a degree measurement, so I apologize if you got confused. That is the distance from here to here. So I apologize if that confused you.
so since it's 150, that's obviously half of 300. So since half of 300 is 150, 150 is equal to 120 degrees for the distance of F and G. That must mean that 300 is 240, since it's twice the amount of second of Main Street.
Okay? Well, yeah, it was an outstanding effort, and I followed your logic, although you kind of threw in some things and you kind of butchered some things. But, okay, but can you do that?
Yes.
Can you do that?
Yes,
John, can you do that?
yes, because since all of those angles on the transversal are congruent, then the lines are parallel, and then you can use two transversal or proportionality theorem.
Wow. I gotta say that his explanation was right on point. He used terminology that was beautiful because I'm going to repeat what he said. You can't say it any better, but I just want to clarify. Because the three angles along this transversal are all congruent, that means that Main Street, 2nd Street, and South Main Street are all parallel. You had to prove that first if you want to use the two transversal proportionality theorem because it's based on parallel lines. If you jump that step and just start forming proportions, you didn't do your job well enough because your case is going to get thrown out in front of a judge. In this case, that's. So now that we know that these three lines or streets are parallel because of John's investigative work, now we can go to Nathaniel's logic. And he was trying to say something about the 150 and the 300 and the 120 and this. Can someone put it into a little more simple terms or just kind of clear up any confusion? Zimar?
I divided 150 by 300.
Mm-hmm.
And multiplied that by. No, wait.
Okay, you're confused. I thought you wanted to explain, but that's okay. Kadir?
The lines are parallel, like they separate like a transversal by like the proportion.
Okay. Yep.
And so like in proportion, like 150 over 300 will be 1 over 2.
150 over 300, and then you simplify that, and it's 1 over 2.
And so since you're trying to, since you need to find the distance between South Main Street and Main Street, which is a FH, you use up another proportion, so it'll be like 120 over X.
Like so?
Yeah.
Okay. And so I think what Nathaniel was trying to indicate that you were able to do this mentally by just looking and saying, oh, well, since this is proportional, this distance is double this one, so this distance must be double this one. So you came up, Nathaniel, with HG equal to what? So this was 240 units. But I didn't ask you for HG, I asked for HF. And so if you add these two together, of course you get 360. Any comments, questions? Yeah, anything you figured out, any observations, anything?
I don't know if this is what you were talking about,
But hold on. I just want to go.
but like, if you take like
The whole distance. Use letters. Use whatever you need to describe. Oh, which picture did you want? Oh, the checkpoint. Okay, yeah, go ahead.
Yeah, like if you take BC and then AC and then you put it, you set it to DC and BC proportionally, it comes out, like when you solve it, it comes out like
Okay. So you are theorizing that there is a relationship we know based on the theorem that this to this will equal this to this. Now you're saying that if we take the whole distance from here all the way to here, which is given right here, 36, and form a proportion with this segment here, which is 20, that will equal the whole distance here, which is given to us in this text, 27 to 15. And you said it works? So let's quit. They both come out to 9 over 5, so it works. Do you think it works every time? Maybe. What if we looked at this one? Do you think it works here? Test out your theory. See if it works. We're going to come back to you in a little while. Checkpoint number 2. Now you're working independently, but I want to clarify a couple of things. This is the exact same picture that I showed you earlier. That is the demonstration of one-point perspective. And I also want to explain in here that the text got cut and went to the next line. This is saying that all 4 of these segments are parallel. That, and that are all parallel. Okay? So read the question. Find me what I'm asking you to find me. You've got, I'll put 4 minutes on the clock to give my students who are testing out theories time to test out their theories as well. And of course, if there's time left, team talk and see if you got the same solutions.
Smoke bud like
Because 45 can't be divided. Constant alignment. It's making it bigger.
Wait, you take me this one.
That's it. I get it. I see what you mean. Make it like easier.
I am doing it.
Alright, done.
would like the measurements of LM and MN to the nearest tenth. You've had an opportunity to explore and discuss with your team. Let's see how we did. I've got students 4, 5, 8, and 16. Student number 4, what'd you get?
LM equals 2.8 and MN equals 4.5.
Okay, student number 5, what'd you get?
Same thing as
Same thing. Student number 8, what'd you get? Student number 16, what'd you get?
LM is 2.8 and
Okay, so I will accept both answers because it kind of depends on how you approached it. If you found LM first and put in a 2.8 and then used the 2.8 for MN, so you formed a proportion with these two and these two, then you would get, I think, 4.4. Because we rounded the 2.8, we're missing a little bit of information. If you went back and used this, 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 and then x, which you could have, then you would end up with 4.5 approximately. So I'll accept both answers. Does anyone have any concerns or issues at all? What do you think about your theory? It works. It worked. Did it work here?
Because yesterday on the organic stuff, I was doing it like my way because I thought I was able to do it, and I realized I wasn't wrong.
It worked anyway. And so you said it here. You didn't test it here, or you did? Okay. What about in this one here? Did you figure it out here? And it works. So the whole distance to one of the shorter distances to the whole distance to one of the shortest distances will come out equal if the lines are parallel. Very interesting theory. All right. Any comments or questions on checkpoint number 2? Okay, so let's finish up with the last idea of the day, which is using the triangle angle bisector theorem. That's a 7, that's the distance here. That's a 13, that's the distance here. This is unknown, and that's what we're looking for. This is not labeled at all, and then we have 15 for the distance of QS. Find RS. So again, this is an exploration. This is not a checkpoint to test your understanding. This is for you to explore. There's no right or wrong. This is just trying to develop an idea. So I want you to spend about 2 minutes with your team to see if you can figure out how to find RS. You can use your cheat sheet, of course. You can use each other. You can work independently. You can talk to me, whatever you need. Go.
Oh, I don't know what to do.
Since they say in the Bible you say 7 over 13 is proportional, and then you say proportional to QR over 5. Since it's x and since we don't know now, we can set it to 15 minus x over x, because you know the whole distance 15 minus subtracting x to find the other distance. So you kind of set like this 7 over 13 equals 15 minus x over 5. And then we can solve from there.
Sorry.
I don't think I need calculator.
Last time we said
Wait, what? Just a guess.
no, but I haven't.
Yeah, 50 minus x over x. Not over 50. Tell me what you got.
All right. What were you able to come up with, if anything? What were you able to come up with? Anyone figure out what RS is? Or think they did? Go ahead, Sharik, you think you got it?
Yeah,
What does it come out to?
I think RS equals 48.75.
Think it equals what? Just say it again, I can't hear you.
No, wait. Oh, wait, never mind. I did something wrong.
Okay, anyone else? Okay, so what's the hiccup? What's the sticking point here? Why is this more difficult? John?
Because it only gives us the total distance of QX instead of giving it the QR and RS separately.
Okay. Okay. Well, let's back up. I've let the cat out of the bag, and I said that we're going to use the triangle angle bisector theorem. So that theorem says that there is a relationship between, if this is an angle bisector, this to this will be proportional to this, okay? So let's put that down so that we've got something to work with. QR to RS is going to equal, based on the theorem, QP to SP. Those should be equal to each other. So now we've got something to build on, something to work with. Let's do this. John said the hiccup is that we don't know something that we need to know. Let's fill in what we know. QR is a big question mark. We don't know it at all. What about RX? Is X equals QP is 7, it's right there, and SP is 13, that's right there. So we've got a lot of what we need, but we're missing something. Oh, we got some light bulbs, Valerie?
I was thinking with the place where you put the question mark, you can put 15 minus x.
You could put 15 minus X. You think that would work? Yeah, I was actually surprised to hear John, of all people, to say what the hiccup was, because I would have bet $1 million that he would have been the first person to figure it out, because he's the one who pointed it out earlier. Let's go back. And let's look at where John pointed something that at the time I think most of you thought was simple. How did we get that number right there? I just circled it in purple, the 16. How did we get that? John explained it quite clearly. How did we get it? Eric, you don't remember how we got it? Well, can you look at it right now and tell me how we got it? I know I put you on the spot a little bit, but that's okay. You can do it.
We subtracted 20 centimeters from the total,
What's the total?
36 centimeters.
That's right. Subtracted the 20, this piece, from the total which was given to us. So if you subtract this piece from the total, you get the other piece, right? So now let's apply that same logic to what we're working on now, which Valerie stated quite beautifully, that if the whole distance is 15, and we know this distance, if we subtract this from this, we get the other one. So she is spot on that that is going to be 15 minus x. And so, and she also said beautifully, if you replace this question mark that she wrote with 15 minus x, then you can actually solve to find the missing piece of information. I'm not saying that that was easy, but if you think about the logic behind it, it's something that you've known for a while. Any questions about that? Good, now find the distance. Go. You already found it? Oh, you already found it? Oh. Give me a thumbs up if you've already got it. Okay, a few people got it already. So you either have already got it or you're finding it right now. We are looking still for x, which really is rs. That's what I'm looking for, rs. So Valerie, you were the one who was able to bring us to this point. So what does rs come out to? What is it? 9.75. Is that right?
Yeah, most likely.
Most likely. Thank you for that help. Yeah, it comes out to 9.75, absolutely. Because we are looking for this distance from here to here. Once you solve for x, that's what the label is, then we've got rs. Okay? Anyone have any comments or questions? If I asked you for QR, could you now find QR? Of course. Any questions or concerns? So let's finish out the day strongly by figuring this one out. I would like the distances PS and SR. PS and SR.
Oh my God, smart. Yes, I am smart. Like profile for 45.
All right. Let's see what we were able to come up with. I need the distances PS and SR. What did you come up with? Student number 18, 5, 17, and 16. Student number 18, what'd you come up with?
Yes, I got 28, and for SR I got 35.
Okay, student number 5, what'd you come up with?
PS equals 28, SR equals 35.
So you agree with Stephanie. Student number 17.
PS equals 28, that's how equals 35.
Student number 16. Any concerns about this? Any concerns? Okay, you guys did quite well today. Draw a line across your paper. And your homework, page 394, you're doing numbers 3 through 19, 21 and 24, parts A, B, and C. It comes out to 21 points because we're counting A, B, and C separately. So when you grade it, grade them separately. And you will have your test, I'm sorry, a quiz, I apologize, a quiz next week, but I'm still not sure when because I'm not quite sure about the writing test schedule and other interruptions that are going to happen.